Download this code from codegive.com, link in the description below. OK, let's dive into the process of deriving a long-run equation and building a model in EViews, complete with code examples and a detailed explanation. This is a common task in econometrics, particularly when dealing with time series data and cointegration analysis. Understanding the concept, long-run relationships and cointegration. Before we jump into EViews, it's essential to understand the underlying principles. Stationarity. A time series is stationary if its statistical properties, mean, variance, autocovariance, do not change over time. Many economic time series are non-stationary in their levels, example GDP, inflation, interest rates. They often exhibit trends or random walks. Non-stationary variables in regression. Running a regression with non-stationary variables can lead to spurious regression. You might find statistically significant relationships that are purely coincidental because both variables share a common trend, example ice cream sales and the stock market rising over time. Cointegration. Cointegration occurs when two or more non-stationary time series are individually integrated of order d, usually I1, meaning they need to be differenced once to become stationary, but a linear combination of them is stationary, I0. In simpler terms, even though the variables themselves drift over time, they move together in the long run, maintaining a stable relationship. This stable relationship is the long-run equation. Error correction model, ECM. If variables are cointegrated, an ECM can be used to model both the short-run dynamics and the long-run equilibrium. The ECM incorporates the error correction term, ECT, which represents the deviation from the long-run equilibrium and acts as a force pulling the variables back towards that equilibrium. 2. Steps for deriving a long-run equation and building an ECM in EViews. Here's a comprehensive step-by-step guide. 1. Data preparation and loading into EViews. Gather data. Collect your time series data. Ensure the data spans a reasonable time period. Common examples include macroeconomic variables, GDP, consumption, investment, interest rates, inflation, financial data, stock prices, exchange rates, or sector-specific data, example agricultural prices, energy consumption. Organize data. Arrange your data in a spreadsheet, Excel, CSV, or a format EViews can read. Ensure you have a column for the date/time period and columns for each variable. Import data into EViews. Open EViews. Go to File, Open EViews Work File. Select the appropriate file type and choose your data file. Follow the import wizard to specify the date/time frequency and variable names. 2. Unit root testing, testing for stationarity. Purpose. Determine the order of integration for each variable, I0, I1, I2, etc. This is crucial for identifying potentially cointegrated variables. Augmented Dickey-Fuller, ADF, test a common unit root test. EViews code interpretation null hypothesis the variable has a unit root, is non-stationary. Alternative hypothesis the variable is stationary. Examine the p-value. If p-value significance level, example 0.05, reject the null hypothesis. The variable is stationary at that level or difference. If p-value significance level, fail to reject the null hypothesis. The variable has a unit root and is likely non-stationary. you'll need to difference it and retest. Asterisk repeat the ADF test for each variable, x1, x2, etc., in levels and in first differences, and possibly higher order differences if necessary, until you find the order of integration. Asterisk Phillips Perron, pp. Test asterisk another common unit root test. It's less sensitive to the lag length selection than the ADF test. Asterisk EViews code asterisk. Asterisk interpretation asterisk same as the ADF test. Asterisk important considerations asterisk. Asterisk trend and intercept asterisk the ADF and PP tests allow you to include a constant, intercept, a trend, or both in the test regression. The appropriate specification depends on the characteristics of your data. If you visually observe a trend, include it in the test. If your data appears to fluctuate around a mean, include a constant. Asterisk lag length asterisk the ADF test requires you to specify the number of lags to include in the test regression. Use information criteria, AIC, SIC, HQIC, to guide your lag length selection. EViews typically offers automatic lag length selection. Asterisk order of integration asterisk based on the unit root tests, determine the order of integration, I0, I1, I2, etc., for each variable. Most economic time series are I1. 3. Cointegration testing, testing for a long-run relationship. Asterisk Engel-Granger two-step method asterisk a classic approach to testing for cointegration. Asterisk step 1, estimate the long-run regression asterisk. Asterisk regress one of the I1 variables on the other I1 variables. This is your candidate long-run equation. Asterisk EViews code asterisk. This creates an equation object named LR_EQ and estimates the regression of y on a constant, c, x1, and x2. Asterisk step 2, extract the residuals asterisk. Asterisk save the residuals from the long-run regression. These residuals represent the deviations from the estimated long-run relationship. Asterisk EViews code asterisk. This creates a new series named residuals containing the residuals from the LR_EQ equation. Asterisk step 3, test the residuals for stationarity asterisk. Asterisk perform a unit root test, ADF or PP, on the residuals. If the residuals are stationary, I0, it indicates that the variables are cointegrated. Asterisk it is important to note that the critical values for this ADF/PP test are different than the standard ones. You need to use the Engel-Granger critical values. These can be found in econometric textbooks or online resources. Asterisk EViews does not automatically provide these critical values. Asterisk EViews code asterisk. Asterisk interpretation asterisk. Asterisk if the residuals are stationary, p-value critical value from Engel-Granger tables, conclude that the variables are cointegrated. Asterisk if the residuals are non-stationary, conclude that there is no cointegration. Asterisk Johansson cointegration test asterisk a more sophisticated test that can handle multiple cointegrating relationships. Asterisk EViews code asterisk. Asterisk the .ls14 specifies that the var has lags from 1 to 4. Adjust as necessary based on lag selection criteria. Asterisk interpretation asterisk. Asterisk the Johansson test provides two test statistics, the trace statistic and the maximum eigenvalue statistic. Asterisk examine the output. The test output will give you the critical values and p-values for each statistic and for each possible number of cointegrating relationships, r equals 0, r equals 1, r equals 2, etc. Asterisk start with r equals 0, no cointegrating relationships. If you reject the null hypothesis, p-value significance level, it means there is at least one cointegrating relationship. Asterisk then, move to r equals 1. If you reject this null, it means there are at least two cointegrating relationships. Asterisk continue until you fail to reject the null hypothesis. The number of cointegrating relationships you found before you failed to reject is your estimate of the number of cointegrating vectors. Asterisk important to check the eigenvalues of the var model before you can conduct the Johansen test to make sure the model is stable. 4. Estimating the error correction model, ECM. Asterisk purpose asterisk capture both the short-run dynamics and the long-run equilibrium relationship. Asterisk steps asterisk. Asterisk calculate the error correction term, ECT. Asterisk this is the lagged residuals from the long-run regression, using the Engel-Granger method. Asterisk EViews code asterisk. Asterisk estimate the ECM asterisk. Asterisk regress the first difference of one of the variables on. Asterisk lagged differences of all variables, including the dependent variable. Asterisk the error correction term, ECT. Asterisk EViews code asterisk. This estimates the ECM with d, y, as the dependent variable, a constant, lagged differences of x1 and x2, and the lagged error correction term ECT, -1. You may need to add lagged differenced variables, e.g. d, x1, -1, depending on the dynamics of your data. Asterisk repeat for other ECMs asterisk you can estimate an ECM for each of the cointegrated variables. However, only one of the ECMs is typically interpreted as the equilibrium relationship. The variable whose ECM is chosen is considered the endogenous variable, adjusting to maintain equilibrium, while the other variables are exogenous. 5. Interpreting the ECM results asterisk asterisk. Asterisk coefficient on ECT asterisk. Asterisk the coefficient on the ECT term should be negative and statistically significant. This indicates that when the system deviates from its long-run equilibrium, there is a force pulling it back towards the equilibrium. Asterisk the magnitude of the coefficient on the ECT indicates the speed of adjustment back to the long-run equilibrium. A larger, more negative, coefficient means a faster adjustment. Asterisk coefficients on lagged differences asterisk. Asterisk these coefficients capture the short-run dynamics of the variables. They show how changes in one variable affect changes in another variable in the short term. Asterisk statistical significance asterisk check the statistical significance of all coefficients. Insignificant coefficients may need to be removed, or the model may need to be respecified. Asterisk model diagnostics asterisk perform diagnostic tests on the ECM residuals. Asterisk autocorrelation asterisk test for autocorrelation in the residuals, example using the Briusk-Godfrey LM test. Autocorrelation indicates that the model is not fully capturing the dynamics of the data. Add more lags or consider a different model specification. Asterisk heteroscedasticity asterisk test for heteroscedasticity, example using the White test. Heteroscedasticity means the variance of the residuals is not constant. Consider using robust standard errors or transforming the variables. Asterisk normality asterisk test for normality of the residuals, example using the Yark-Barrett test. Normality is not strictly required for consistent estimation, but it is desirable for inference. 3. Code example, complete workflow. 4. Important considerations and tips asterisk asterisk. Asterisk lag length selection asterisk carefully choose the lag length for the ADF tests, var model, in Johansen testing, and ECM. Use information criteria, AIC, SIC, HQIC, to guide your selection. Experiment with different lag lengths to see how they affect the results. Asterisk deterministic components asterisk decide whether to include a constant, a trend, or both in the unit root tests and cointegration tests. The appropriate choice depends on the characteristics of your data. Asterisk sample size asterisk cointegration tests require a sufficient sample size. Small sample sizes can lead to unreliable results. Asterisk multiple cointegrating relationships asterisk if the Johansson test indicates multiple cointegrating relationships, you'll need to interpret all of them. Asterisk economic theory asterisk let economic theory guide your model specification. The variables you include and the relationships you estimate should be based on sound economic reasoning. Asterisk robustness checks asterisk perform robustness checks by using different unit root tests, cointegration tests, and lag lengths to see if your results are consistent. Asterisk software asterisk EViews is a powerful tool for time series analysis, but other econometric software packages, Stata, R, Python with stats models, can also be used to perform these analyses. By following these steps and carefully considering the underlying principles, you can successfully derive a long-run equation, estimate an error correction model, and gain valuable insights into the relationships among your time series variables. Remember to always interpret your results in the context of your specific research question and economic theory. Good luck.